Okay, so today I will be teaching you how to solve simultaneous equations. Generally speaking, simultaneous equations are when we have two equations with two unknown variables. And finding out these unknown variables will lead us to find out where these two equations intersect. So in example 1, we have 3x plus 4y equals 26 and 7x minus y equals 9. So the first step is to eliminate any variable of your choice. I can see that I can eliminate y by multiplying this bottom equation by 4. By multiplying it by 4, I get 28x minus 4y equals 36. And the top equation remains the same. So 3x plus 4y equals 26. Now I can just add these two equations together and I get 31x plus 4y, take away 4y equals 0. So 31x equals 26 plus 36, which is 62. Now just by simplifying down, I can get x equals 2 because 62 divided by 31 is 2. Now we found the x coordinate. We can just plug in x into any of these equations. I will do 7x minus y. So 7 times 2 is 14. Minus y equals 9. Just by rearranging the equation, we can get 14 take away 9, which is 5, equals y. So y equals 5. Now the coordinates of the intersection point are 2, 5. And for a sanity check, we can just plug 2 into this equation and plug 5 into the same equation. So 3 times 2 is 6, 4 times 5 is 20, 6 plus 20 equals 26, and that checks out, so it's correct. Moving on to example 2. Find the intersection point of these two equations. Y equals 4x minus 26 and y equals minus 3x plus 16. It's similar to the first equation, it's just written in a different format. So we have y equals 4x minus 26 and y equals minus 3x plus 16. So we can just write that as 4x minus 26 is equal to minus 3x plus 16. So now what we do here, we get the unknown variable on one side and the number on the other side. So to do that, we can add 3x to both sides and plus 26 to both sides. So we get 7x is equal to 26 add 16 is 42. And by simplifying down, we can get x equals 42 divided by 7, which is 6. Now, to get the y coordinate, we just plug 6 into any of these equations. I'm going to plug it into this one because it just seems easier. So 4 times 6 is 24. Take away 26 equals minus 2. For a sanity check, we can put in 6 into this equation. So 3 times 6 is 18. So don't forget the minus. So it becomes minus 18. Plus 16 equals, again, minus 2. Therefore, we know that the point of intersection of these two equations will be 6, minus 2. Moving on to the third equation and the third question and final question. We've got a quadratic and a line. So we've got y equals x squared plus 2x plus 3 and y equals x plus 9. It's similar to the second equation. We can just write that out as x squared plus 2x plus 3 is equal to x plus 9. Now the difference here is that we don't want the variables and numbers on separate sides. We want them on the same side because it's a quadratic. So we take x from both sides, x squared plus x, and we take the 9 from both sides, which will give us minus 6, and then equals 0. Now from here we can see that we can factorize this, and the factors of this are x plus 3 and x minus 2 equals 0. So when x plus 3 equals 0, that must mean x equals minus 3, and when x minus 2 equals 0, that must mean x is plus 2. Now to find the intersection points, we just stick these two x coordinates into any of the y equations, but I'm going to choose this one because it's just simpler. So y equals minus 3 plus 9, which equals 6. So minus 3 comma 6 is the intersection point of one of the intersection points, and the other one is y equals 2 plus 9, which is 11. So 2 comma 11. And again, the sanity check would be just to put these x coordinates into this equation, and you should get minus 3 comma 6 and 2 comma 11. That's how to do simultaneous equations, and goodbye.